let's finish up and do the last one here. So you can actually do this one by just doing all equations, but it's helpful to be able to visualize what's happening as well. So we have two lenses. So I drew two lenses. They're 20 centimeters apart. The focal length of the first one is 10, so half the distance, that's f, the focal length of this one. And they're both converging lenses. So we don't have to worry about the second lens yet. Let's see where the image is going to be formed with the first lens. So the object, let's see where it is. The object is 15 centimeters to the left of the first lens. So that means that this would be 20, so 15 would be right here. So the object is over here. So where is that going to produce an image? Don't want to do it too big. So you go parallel, and then it's going to go straight through. And then you're going to have it go through the focal point on this side. As soon as it hits the lens, it's going to go parallel, and we're completely ignoring the second lens right now. We're pretending that this second lens is not even there. And you draw the third one as well, that goes through the center. And if you did it correctly, I'm just doing a rough sketch, you do see that they all intersect over here, and that we get an image over here. So where will the final image appear as measured from the 20 centimeter lens, as measured from this lens? But this is not the final image yet. This is the image formed by the first lens, where we completely ignore the second lens. Now what we need to do is completely ignore the first lens so we can redraw it underneath, so that we don't have to erase everything we just did, but all we care about now is the second lens and the fact that the second image is right here. Where is that going to produce the final image? So the focal point of the second one was 20 centimeters away, and it ends up being that it's further to the right. Again, I'm not drawn to scale, but you can see just from this rough sketch that this was 20, so the focal point is more to the right, somewhere over here is f2. And it's also over here, because it's 20 centimeters to from each side of the lens. So how are you going to form an image from an object that is on the right side of the lens? Now, that is a harder diagram, so you're not going to be responsible for doing one of these, but I'm just going to show it just so you see where the final image actually does form. So I'm going to make my lens just a little longer. But the way that you would do this one is, well, you're going to have a ray that's coming parallel. It's not going to hit the object, but as it's coming parallel at the same size as though it would hit the object, but as soon as it hits the lens, it still needs to refract through that focal point. Again, you're not going to have to do one of these, but I just want to show it to you. This should be a straight line here. And then the second ray that you can draw is, it's going to have to go through the focal point on this side and then refract parallel. So what you do is you imagine a line that hits the tip, and you're going to go towards that line, but as soon as you hit the lens, you're going to refract parallel. And then you could do a third one that is coming from the center towards the object and just keeps going through the center. But I didn't draw mine perfectly, but what does happen is that all those three rays, they do meet somewhere here, which shows you that the image is going to be formed here, and it's going to be smaller than the object. So again, you don't have to do this rough sketch. We've never done an object to the right of the lens, but I just wanted to show it to you. On a test, you would have the object would always be on the left of the lens. And you need to know how to use the equations to find, well, where exactly is this image. So we consider the first lens first. So for the first lens, we're going to write down our givens. P1, the original object distance, was 15 centimeters. The focal length for the first one was 10 centimeters. And we can find Q using the thin lens equation, PF over P minus F, and we get 30 centimeters. According to my drawing, that image, if this was 20, should have been maybe a tiny bit right here, but it was pretty close. But it should have been right here. And now the trick is to figure out the right numbers to plug in for the second lens. You can't just say, oh, my P is going to be 30, because Q is 30 from the first lens, but the two lenses were already 20 centimeters apart, so that means that this is only 10 centimeters. Because from this lens to this one is supposed to be 30. So that means that now when we're just considering this lens, that this is the new object right here, it's only 10 centimeters away from the lens. So P is 10. But the object is behind the lens, so we said that's a negative object distance. So again, even though you don't have to draw one of these, for this particular case, you do have to be able to figure out, okay, if it's 30 centimeters from the first lens, then it's only 10 centimeters from the second lens, and that's going to be my object distance. Focal length of the second one is 20 centimeters. So once again, we need to find Q, P2 times F2 over P minus F. And this time, we're going to get 6.67. And if you see my original picture, if this was supposed to be 10, well, this is to the left, so it is smaller than 10.